In Lesson 6.2, we will be solving systems using the substitution method. So in 6.1, you had some practice solving the system by graphing. Now we will be solving more of an algebraic method. So before we get started, there is one mixed review problem that I would like you to do. So if you want to go ahead and press pause, try it out, and then we'll come back together and the answer will miraculously appear. So hopefully you had a chance to work through the mixed review problem. We were solving for y. So that means we've got to do the opposite and move the x over first. So I subtracted that. Then I need to get rid of the 2, so that means we divide every value by 2. I also went ahead and just put it into slope-intercept form. Why not? And so we end up with y equals negative 2x plus 19 as our equation where y is by itself. Just a little bit of review there as we get going. Today we're going to be talking about systems of equations that can be solved in more than one way. When a system has at least one equation that can be solved quickly for a variable, the system can then be solved efficiently by using what we call the substitution method. Here is an example where we solve a system, and what we see here are two equations, and what we want to do is look to see if there is an equation that can easily be solved for either x or y. You just have to kind of decide what would work best for you there. Now, the book as a solution shows that they are going to take that first equation and just subtract the 2y over so that we now have solved that equation for x. We are in the habit most of the time of solving for y because we're used to dealing with linear relationships, but you can also solve for x. That is definitely a viable option. What we can see here is once we have solved for x, we're going to take that equation and we're going to substitute that equation in for x in the second equation. So what that means is if you look here at the second equation, here is where x is located. So we're going to take what x equals here, which is the 4 minus 2y, and we're going to plug it in for x here, replace the x in that equation. So this is what it's going to look like now. Now we took this and replaced the x, so we have an equation that now only has y as a variable, and then we can solve for y at that point. So we would use the distributive property and we would simplify until we have y by itself. In this case, we get y is 1. Now, once we have a solution for y, we then have to solve for x, because as we know, a system, thinking about graphing, is where the graphs intersect. It's a point. It's an ordered pair. So we can't just have y, we also have to have x, so we have that ordered pair for the solution. So what we can do is substitute our answer for y back into the first equation. So that's what they did here, is they took the original equation and plugged in 1 for y, and that way we can solve for x. So that means that our solution is 2, 1, and we would still write it as an ordered pair, just like we would if we were solving by graphing. So this is kind of the basic idea of the substitution method. As it said earlier, if we look back here, we really use this probably the most when the system can be solved efficiently by quickly solving for a variable. If that isn't always the case, then we can try to think of other methods. But for right now, the next few days, I want you guys just to practice with this method. So we have an example there that's all worked out. You can check your solution. So we would take our ordered pair and we should be able to plug it into both equations and it should work and be true for both equations. So we can always check our work and make sure that we ended up with the right solution. Now, let's look at an example here using substitution. So in this first example, we want to solve the system by using the substitution method. And this is kind of what I consider a nice problem because both equations, as we can see here, are already solved for y. So that makes things rather nice because I can take this first equation for which equals y, and I would just plug it in for y in the second equation. So I don't really have to go through seeing if there's an equation that I can solve for x or y. It's already, that first part is already done for me. So at this point, we would set up our equation. So instead of y here, I'm going to replace it with this whole expression, 2x plus 7. And then that is going to equal the x minus 1. So when I do that substitution, I now have an equation that only has x, and then from there we can solve that equation for our x value. So let's go ahead and do that real quick. So I'm going to combine my x's here. Then we're going to subtract the 7. So we would end up with x is negative 8. Now remember, that is only half the problem. We also have to solve for y. So it really doesn't matter which equation you pick, but you want to pick one of the original equations. So I think I'm just going to pick the second one, and I'm going to take negative 8 and just plug it in for x this time. So I will say y equals negative 8 minus 1. That replaced the x, so y is going to be negative 9. And we want to write that as an ordered pair. Our solution then will be negative 8, negative 9. And we should be able to plug that in to both equations, and it should work in order to be a true solution. So checking is always a good idea. So there is our answer. Now, moving on to example 2. It's just another example for solving using substitution, except this time I would consider it not as nice of a problem because obviously neither one is solved for a variable. But what you want to do is ask yourself, well, which equation could be easy to solve for a variable? I would look at this first equation and see, well, y doesn't have a coefficient. So if I were to just move this 2x over, then I could have y by itself. Then I can solve the system pretty easily. So I'm going to choose this first equation here. And I would just add that 2x to move it over to the other side. So y is going to equal 2x plus 3. Now I have an equation where a variable is by itself, and like we talked about earlier, we're going to take this equation for y, and I'm going to plug it in here into this equation where y is located. So it's going to replace the y in the second equation. 3x minus 2, instead of y, we will have 2x plus 3 equals 5. Now at this point, you're able to solve this equation because we only have our x variable. So go ahead and do that, and then we will take that answer and we'll have to plug it in to our equation here where we solve for y and get our ordered pair. So let's press pause here. Go ahead and solve that, and then we can come back and you can check your answer. And now we have finished the problem. So you can check to see if you had that question correct. Remember, we took this and plugged it in for y. So we went ahead and worked out the problem. So I combined like terms, added the 6, divided by -1, so we got x is -11. Remember, that's only half the problem. We still have to solve for y. I take my equation here that I had solved for y and plug in -11 for x in that equation. Then we end up with -22 plus 3, which ends up giving us -19. And we would write our solution as an ordered pair. Problem 3 has to do with a word problem format. And right now we're going to skip this as we will spend a whole day, actually several days, working with word problems and systems. So I'm going to hold off on that and we'll get back to that. Now we can look here at our last example for example 4. There are times in a system when we have infinite solutions or no solutions. So I wanted to give you a chance to see a problem like that. In this problem, we're going to, just like we did before, try to solve this system using the substitution method. I'm going to go ahead and take the first equation here and solve that first equation for, I can solve it for y, I can solve it for x. I don't really see an easy way to do this. So I'm going to just pick the first equation and let's solve it for y. So I'm going to pause and do that real quick, and then we'll come back together. Now, as I said, I took the first equation and I solved it for y. So I subtracted the 5x and then divided every value by 6. So I do have fractions, which happens occasionally. What I'm going to do here is I'm going to take this and plug it in for y in the second equation. I can't plug it back into the first because that's the one I solved for. So you've got to plug it into the second for y. And once I use distributive property, 3 times the 4/3 would give me 4. And then 3 times 5/6 ends up giving me 2.5. Now I'm going to run out of time here, so I'm going to pause it real quick, finish the problem, and do a quick wrap up. And quickly solving this equation, I can see that the 2.5x minus the 2.5x will cancel, and we're left with 4 equals 4, which is infinite.